Hi students, now we are going to look at AC generator. So you might have not come across this diagram because just in taking the class from the engineering concept. So let you all know the skeletal structure of the AC generator, right? First, draw the diagram. So what I am drawing is the armature of the AC generator. You know what is meant by armature? I will explain you later. So this is the armature. This is made up of complete solid soft iron core. But always we need to go for a laminated sheet of soft iron core. So whenever the laminated sheets of this part is combined together, and between each laminated sheet we need to insulate by using oil or mica or the paper, right? So these are the laminated sheets. So in between each laminated sheet, we are insulating with a paper. So why do we go for the laminated sheet of soft iron core? And what is the purpose of using the soft iron core? See, the soft iron core we use mostly prefer for AC generator because it can get easily magnetized. It can get easily magnetized, as well as why do we go for the laminated sheet of soft iron core? Because when we use a complete solid core of armature, then it will create some eddy current, or else it is called as Foucault current. The current will increase the weight of the armature, so that the generator or whenever the armature is rotating, it will try to stop quickly. So whenever it stops, what will happen to the output? The output will change. So we cannot get the expected output. So in order to avoid the Foucault current or eddy current, we need to use a laminated armature, right? This is what we call as an armature. So I think you can understand the laminated sheets here. So all the laminated sheets are bunched together and form as a soft iron core. And what is the purpose of using this armature? Two purposes we are using this armature. First, to support the coils. So this hollow region is called as the slot, where we can wind some n number of turns of coils, n number of turns of copper coils which are insulated, right? So in each slot, for example, in this slot, which is quite opposite to this, right? So I can wind some 100 turns of coil over it, right? Like that, in each slot, I can wind some n number of turns of coil. So the armature purpose is used to support the coils. Not only to support the coils, also it is used to produce more magnetic flux. So let us see about it. Now here there is a hole. Through the hole a shaft is connected. Now I am going to connect or place a rectangular coil of wire on this slot, and that coil of wire, so opposite to this slot is this one. So this is P, Q, there are, this is S. So it's a rectangular coil which is called insulated copper coil placed on the slot of the armature, and then it is connected or fixed along with the shaft. As this shaft rotates, along with the shaft, the armature also rotates. So when the armature rotates, so the armature is kept in between the pole pieces. So as the armature rotates, it cuts the magnetic flux. So the magnetic flux will be linked with each turn of the coil which has been placed on each slot. So due to the flux linkage, what will happen? So according to the electromagnetic induction, what is the definition? Whenever there is a change in flux linked with each conductor or linked with each turn of the coil of a conductor, an EMF is induced. So when an EMF is induced, that EMF is called as induced EMF, and that current is called as induced current, right? So that will be produced. Now, here we are going to place two slip rings, R1 and then R2, and these two slip rings, they are used to produce the sinusoidal current or voltage, right? So this is used to convert the wave. For example, the first half cycle of the wave, we know that the crest part. The second half of the cycle, we know that the trough part. So we get a full cycle. So in order to produce the full cycle of the voltage or the current, we need to go for the slip rings. Two slip rings are connected with the shaft, also with the turns of coil. So for each turn of coil, we have to connect two slip rings, and two brushes made up of carbon are fixed, or we should not say it is fixed, it has been pressed against the slip rings R1 and R2. Here the brush B1, B2. So why do we go for brushes? Because what will be the output collected from the generator here, externally it is collected through brushes and then sent to the input of a transformer. So a transformer can step up or step down the voltage which is coming through the brushes. So the brush is used to collect all the output current or voltage through them, right? So these are the components. So armature, which carries or supports the coils, the rings, slip rings, which produces a sinusoidal wave like, so the full cycle of wave, the brushes, which collects the current and then passes through the external circuit, right? This is all about the component. Now, here, what about the magnetic poles? For example, I am going to show you the front view of a generator in a simpler way. These are the poles. These are the poles. This is the armature, and here the shaft is connected. Here, if this is north pole, this is south pole, this is north pole, this is south pole. Even in order to magnetize the pole, we need to go for a DC generator. So here, these copper coils are connected to a DC generator, right? So this DC generator in each pole will produce DC current which will pass through the coil So whenever current passes through each turn of coil, flux will be produced. That will magnetize the each poles here. So this is how it is getting magnetized. Okay. Now there should be a less gap between the pole and the armature, so that more magnetic flux can be produced as the armature rotates. So it cuts more number of magnetic lines or poles, right? Now, let me rub this diagram. To understand AC generator easily, I am going to give some hints for you. So, this is the rectangular coil, A, B, C, D. These are the slip rings, R1, R2, and brush B1 here, brush B2 here, so external resistance, right? Now, if this is rotated in a clockwise direction, now first uses. What is the use of an AC generator? It is used to convert the mechanical energy into the electrical energy, right? Next, uses over the principle. So, the AC generator works under the principle of electromagnetic induction. So, whenever there is a change in flux linked with a conductor, an EMF is produced, right? Third one, see the polarity of the wave or the voltage or current will be changed in every upper rotation. Okay, so for example, like this, for E, for I as well. Now, in first half rotation, what will happen? We are going to see. So, in the first half rotation, AB comes up and CD goes down. Now, externally and internally, we are going to see how the current flows. So, the current flows internally A, B, C, D. So, the current flows from A to B, C to D like that. Internally. So, externally, it flows from, the current flows from the brush B2 to B1. Now, in the second half rotation, so the wave will be like this. The wave will be like this. 0, 90 and 180. The second half rotation. So here DC will come up and AB will go down. So the current, so internally will flow from DCBA, but this is internally, but externally it goes from the brush B1 to B2. So these are the keys to understand about the AC generator, and the diagram for this second half is will be like this. So if they are combined, we will get a full cycle of wave. Okay. So the sinusoidal voltage or sinusoidal current will be E is equal to E naught sin omega t, I is equal to I naught sin omega t, where E naught is the peak value of EMF, I naught is the peak value of current. Here the I are the instantaneous EMFs and currents respectively. So I think you must have understood the concept clearly. Thank you, students.